All right, class, good evening. Let's see, we're moving on to lesson 6, list tuples and string manipulations. There's also another object type in there called a dictionary. And the dictionary is going to be the key here to your individual lab, because what you're going to do is look for a key or value and return the opposite. Easy to do once we cover this lesson. But see, these object types, list tuples, and strings are important because chances are you're going to be working with a group of data. And a lot of times you'll have things like a list of computer names, list of IP addresses, list of files, or a dictionary of locations of files and file names or updates. And you can rip through them really easy with Python and get a lot done with automation. So here's the reading. Here's all the fun stuff we're going to learn. Group activities, output some numbers to a list. That's pretty easy. You use the append method on a list object. I'll show you how to do that. Challenges, of course, and then you have your state abbreviations lab. Um, and the state abbreviations are nothing more than a key value pair. So the state will be the key, abbreviation will be the value, or you could flip it. It's up to you, whichever is easiest. Now let's dive right into the lesson. I'm just going to hit F5 here. Scroll up here, move a couple things. Put this over here. Minimize that. Okay, so a list. Let's talk about what a list is. It's a data structure that holds an ordered collection of items. The ordered part's kind of important because it has an index number. So here we create a list by calling on a variable, creating a variable equals square bracket, close square bracket. And our first object in index 0 is apple, mango, carrot, banana. And then we print the variable name, and then the output is the entire list. Not too bad. A couple different ways you can make an empty list. Sometimes you need an empty list object to fill it later. What if you had a list of computer names, so just say computers, and you had active and off? You created two other empty lists called active and off. And you said, for each computer in my computers, run a ping test. If it comes back true, add to active, else add to off. So that you can have two lists of machines that are on or that you completed a task on, and then the secondary list, which you missed or have to go back and update later, right? A lot of different ways you could use lists, right? So how do you create an empty one? Well, pretty simple. Call the list function, open, close parentheses, store it in a variable. That'll give you an empty list. Now you could also just say var list equals list equals open close brackets, and it'll create the same thing, an empty list, right? Two different ways you could do that. You would call the list and print it. Now you could call on, you can make ranges of numbers super quick by using range, quick list. Call the list function, call the range function, give it a stop, print your range, 0 through 2, no problem. Now, everything you learned in lesson 5, a lot of it has very similar techniques to slicing anyway. The slicing you could use on a list. So what do I mean by that? Well, here we have a list of cheeses, and I call on cheeses index 1. And there it is. Not bad, right? Well, a list can have multiple different types of objects in the list object itself. So a list is nothing more than an object of objects. And you see here, we have a string, a float, an integer, and another list with integers, all inside mixed list. No problem. You can do that. All right, perfect. Now here we have a bill list, but we call on electric 50, gas 60. So the name of the bill is in index 0 in each list, and the cost is in index 1. So if you call on 10, 10 should be gas, right? Because this itself is index 0, and then itself has a 0 and a 1. This is index 1, and we called on 0, so here we have gas. So you could do lists in lists, nested lists, right? If you have something like this, it may be better to use a dictionary. It really depends on what you're trying to complete, but we'll talk about that as we get into dictionaries. Here's some more examples of slicing. Well, actually, this is printing 3 different lists. So we have the cheese lists, and numbers with some integers and an empty list. And we say print, and we call them all by variable names. And guess what you get? You got your empty, your numbers, and your cheeses. So you can call them multiple lists at a time. Here's a mutable example. Numbers 17, 123. I'm going to say slice 1 is 5, and then call all my numbers. So what we did here is we changed the value of a particular indice. It's no longer 1, 2, 3. We made it 5. We printed it. That's exactly what happened. So we updated our numbers. Now, can you have another variable name in front of this? Like number 2 equals numbers, 1 equals 5. It'll still change your numbers. So just keep that in mind. Let's see, got a print here. There we go. What do we got going on here? So we got some functions that work with lists. Got our list of numbers. Length of numbers, of course, will tell you how many objects are in it. We got 6. The max, since they're integers, it'll tell you the highest value. The min, and another cool one is sum. So you can sum these up relatively quickly. Boom, there you go. You don't have to go 0 plus 1 plus 2 plus 3 plus 4, or do some type of for loop or something. You can just bang sum, no problem. Now we have move on to the cheeses, right? So here we have a list of 3 cheeses called the length, tells you how many objects are in it, 3. Max cheeses Gouda, min cheeses cheddar. Excuse me. Now what this does is it looks at the value of the first string and gets the value of that particular string in Unicode. So not very helpful unless you know all the Unicode numbers. It does not do it alphabetically. You can add like a small c in there and an A and a capital A and a lowercase a, and they'll have different values as well. If you go to Summit, it'll fail. It'll say cannot perform operation, obviously because it's not a type of an integer or a float, right? So we got some more lists. Here we say length of my list. We got 1, 2, 3, and then there's something else in here. 4. So we have 2 lists inside a list, plus an integer and a string. So when we call in the length, we only get 4. It does not call in the length of each indice. Now, if we called on indice 2, if we did this, right? If we said my list 2, 1, 2, and then we got the length of it, we got 3. So you can call on the length of sub lists and lists, but you need to know they're call them on by their slice or indice, right? So how you traverse a list. This is pretty much the most powerful thing with the for loop. So you have your cheeses. For each item in my items, print a piece. In this case, it's for each piece in my cheeses, print a piece. And you have for cheddar and cheeses, print cheddar. For Edam and cheeses, print Edam. For Gouda, print Gouda. That's exactly what you get. Not bad, right? And that's beginning of the list. Let's see what else we got here. Got a couple files to roll through tonight. This should be 2. Let's take a look again. So here we're going to get a little trickier. We're going to say range length of cheeses. Well, what good is that? What you can say for each item in my list of items? It's really up to you, depending on what your goal is. Do you want to do something with an integer of a range? Because here you got the length of cheeses, which will be 1, 2, 3, right? And that'll stop at 3. So for each item in my range, stop at times 2. So now it's calling that indice, right? So here you should have. Let's see where we're at right here. Apple, mango. Where are we at here? Pretty multiples. I didn't run it yet. Silly me. F5, there we go. Scroll back up. So here we have print item and indice 1 twice, or indice 0 twice. So you have cheddar, cheddar, Adam, Adam, Gouda, Gouda, and then it's done, right? No more items in your list. The for loop quits. It's the power of Python. Now here you have A, B, two different lists of integers in a string. And you're saying print A plus B, and then print C. Well, here we go. C is, let's see, what's this? A plus B. So we add the whole thing. Well, not really, because what this did is this took the first list and added the second list to the end of it. So when you print it, you get the first list and the second list right in order. No problem. Lists are like objects. You can add them together because all it does is add the lists. It doesn't add each individual item. That's sum. If you try to sum this, it would fail because it has a string, right? So now I can do some more fun stuff. You could say I have a list of 0 times 4. This is what you get, 4 zeros. I have a list of 1, 2, 3. Now I'm multiplying the list by 3, and that's exactly what you get. It's not each item, it's the list itself, because the list itself is an object. Cheeses, we're back to our cheeses. We print cheeses, no problem, we got it. This is awesome for checking. You get a Boolean back. Gouda in cheeses, true. Think about this. If your boss hands you a file of 10,000 computers and you want to know if one particular computer's in there, you can simply read in the file to a list and say computer X in my list, and it'll come back true or false. That's how fast it is to see if something exists inside a list, right? So print operators, let's see what we got here. Oh, this is fun. This is more slicing. So this is taking a range of slicing. So what we're saying is call out my list, start at 1, go to 3, boom, or stop at 3. So you get 1 and 2. Start at the beginning, stop at 4, 0, 1, 2, 3. Start at 3, go to the end. Start at 3, 0, 1, 2, 3, go to the end. That's what you get. And here we say from the beginning to the end. That's what that is with the little call out a list just with the full colon. And there you go. Right? Cool stuff. More with slicing. So here we have a list with A through F, and we're saying start at 1, stop at 3, so it's BC. But for each of those items equals XY, then print. It swaps out your 1 and 2 with X and Y, and it did update that list. So now T is this list that's highlighted. Sort of cool if you need to replace something in a pinch. Now here comes some methods. Now remember, a method is nothing more than a function of a class. And the class object that we're using right now is a list. And T, the list has an append method, dot append. So we're saying our list dot append D. Well, guess what it does? It adds it to the end. It literally adds it to the end, append. And there's our D. And now it also has an extend, which is moderately different from end. Because now we're saying, or append, excuse me, it's been a long day. So here we're saying A through C, we have our second list. And we're saying our first list, extend it with the second list, then print our first list. And now you see it added both those lists together, right? Perfect, or extended it, right? Sort. Sort's a mystical beast, right? Obviously, this is not in alphabetical order. We take the list, we give it the sort method, we print it, and it is indeed sorted. It goes alphabetical or Unicode values, right? So same thing with integers. It'll sort them numerically. Now here's a reverse sort. You can say sort reverse equals true. So you're calling on the sort method. It has a parameter of reverse equals true. And then we go to print it, and it sorts it and flips it around reverse and then prints it out. Perfect. And here's more with reverse. You got an A, C, E, B, A, print reverse, A, B, E, C, D. This is without sorting it. That's just a reverse. That's just right here. Okay, now we have pop. Pop's pretty cool. Pop on its own, without giving it a parameter or an argument, it'll pop out the last item in the list. So here we have a list, A through E. And there's different, delete's kind of sketchy term, but we'll say, here's our list, X equals T pop 2. Well, 0, 1, 2, right? So we popped it. Cool, we got some people in here. All right. We popped it, printed our list, and then we called on the object that we popped. So this is kind of a way of saving something if you go to remove it from a list. It's pretty handy because you might have to put it back, right? So now you see our list. It's missing C because we popped it out of the list and we stored it in X. Then when we call on X, there's our popped C. Now, if you just call on pop on its own, it'll just remove E. It'll start at the end and start working towards the index 0. If this was just open close parentheses. Let's see what else we have now. We got some differences between remove and delete. So remove X. We got this. We say remove Tim, store it in X, and we print T. We have our list. What happened to Tim? It's none. Well, it removed it. It literally removes it from memory. No longer in T, did not get stored in X. That's what happens when you remove something with the remove method. Now, if you don't want to delete it, you could try, calling on an element and deleting an element. Now, this is kind of wild, right? Check this out. So T equals A through E. I'm saying delete T1, so it'd be B, and print T. Bingo, right there. It is gone. It's deleted. It's not removed. It is deleted. Removed often means you could call on it or attempt to store it somewhere else. In this case, it is deleted, completely removed from memory, right? And let's see what else we got down here. And now I'm saying delete. Here's our list. I'm saying delete from index 0, stop at 6. Well, that's everything. 0, 1, 2, 3, 4, 5, and 6. Saying stop at 6, print T, all I have is an empty list. Now when I go to delete T, I get an error telling me that T is not defined. Because we defined it here, used it here, deleted it, printed it, it's empty. Then I go call on delete T again and go to print it, it's gone. This completely removed the empty objects. This deleted all the objects in T. This removed the list itself. So there's a lot to learn in this lesson, but I think once you master these methods and functions, this becomes a lot more fun working with bigger object types, different object types. Let's talk about strings in a list. So we did a lot of stuff with integers and single strings. Let's move it up to sentences or words or something like a log, right? Hit F5 on this. Go ahead and run it. Where are we at here? Okay. So, list and strings. A list is a sequence of characters, blah, 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 all the fun stuff. But a list of characters is not the same as a string. You have to convert the string to the list, and then you can use it, right? So let's talk about that. So here we have spam, and I create a list of my variable string spam, and I print T. Now it creates a list where every letter is in its own index. That's the difference, right? Now you can say for each item in S, print S, and you'll get SPAM. And same thing as if you say for each item in T, print T, or for each item in T, print item, it'll say SPAM as well. But these are individual objects now in a list. So it's a list object with 4 different string objects. Important differences, right? So print, split some words. Got a string, pining for the fjords. I use split with no parameters. Print T, and this is what I get. Split with no arguments will split a string on a space. So you notice that every space it created, it decided it was a word or an object, and that's how it did that. Same thing now works. We call on slices of 2, 0, 1, 2. We got the, we print right there. Let's talk about delimiters. Split with no arguments splits on a space. Split with an argument will split on that argument. So here we have spam dash spam dash spam, and I say split on the dash. That's exactly what it did. Cool, right? Let's see what we got here. We have, here comes join. Okay, this is the fun part. So pining for the fjords. The delimiter we decided is going to be a space, and we call on delimiter, and then we say join, then we say join each object in my list. So now this is my list, and then when I print it, it's just one long string now, and add the spaces back to reverse the inverse, right? Let's see what else we got here. Aliasing and referencing, 2 different things. This is important. Let's see. Yep, the association of a variable with an object is called a reference. You have to call on the reference in order to print the variable. So let's think about that. A is 1, 2, 3. B equals A. Print B is A. True. B calls on A. It references A. So it's basically the same object, right? Not the coolest thing. Now we have more of fun stuff here. So let me expand this. So an object with one or more reference has more than one name. So you could say that the object is aliased. If the alias object is mutable, can be changed, changes made with one alias affect the other. So if you have an alias and original object, and I say right here, I say A is 1, 2, 3, and I say B is A. So now I have 2 lists of 1, 2, 3. Or do I? This is the important thing to know the difference of, right? And now I say for B, index 0 equals 17. Well, then I print A and B. Well, guess what happens? It changed the index in both. Didn't really change it in both because B just references A, and ideally we said change A0 to 17, even though it's B0, because B is just referencing A. So when we print them, it updates. It looks like it updates 2 objects, but in reality, It just update A because B references A. Do not get caught up in this. If you need to make more objects, make more objects. It only costs memory, right? So, the book says avoid using them while you're with mutable objects. Makes sense, right? Let's see what else we got with this banana. This gets pretty wild with the banana talk. So A equals banana, A equals B. And I say A is B. Remember, is and in are awesome helpers here. And this is, we get true because B is referencing A. It's an alias. And now I say B equals apple. I say print A and B. I get apple, banana. And now I do A is B. And I get a false because I changed the value of B. It's no longer references A. It literally is the string apple. Hope that is helpful. Let's check out lesson number 4. So this comes down to what can you do with all this fun stuff we learned, like slicing and dicing and working with strings. Here you can create a delete the head. So delete the first item in an object or a list. Here we just call it delete head with a parameter. And then we say delete T0. So letters is A. We call on delete head letters, print letters. Let's run it because you're not going to have your A. It removed A. Cool, right? Usable function. You can put all over the place. Have a good time with it. So let's take a look at T1. T1 is 1 and 2. We're going to call on T1 append 3. We're going to store that in T2. And then we're going to print T1. Guess what we get? 1, 2, 3. No problem. Now let's see. We have print T2. Got the stars. You notice T2, which is T1.append 3, it says none. Allow that focus in. Hey, Chris. So now that we call on T2 and our object was appended with 3, we get none. Awesome, right? Let's take a look at add some fun stuff. So we're saying now T1, which is 1, 2, and it appended with 3, so it's 1, 2, 3. We're saying plus a list of 4. Well, it just adds the list of 4 to the end of the list in T3. And then we print it, we get 1, 2, 3, 4. And then we say T2 is T3. Well, T2 is 1, 2, 3. T3 is 1, 2, 3, 4. We get a false. No worries, right? Now, our first function deleted the first item. Our last function deletes the tail. Here we call out a slice from the beginning, starting at the back, 1. So it reads like that, right? Reads C. I believe that's what we did. Let's take a look. We tail letters, we print rest, and there we go. It removes C, just like a boss. Cool. And a lot of this stuff, most of it will work with tuples. We'll talk about those here in a second, I think. I'm going to dive into a dictionary first. So a dictionary is your best bet for your individual lab. It's a key value pair. We're going to build an empty one first. We're going to say English to Spanish equals dictionary. We're going to call the dictionary function open close parameters. And we're going to print it. And there's our empty dictionary. So all we do is create one. Call it a dictionary command. No problem. Now we're going to add some values, keys and values to our dictionary. We call in the dictionary object itself the key name equals the value. Then we print it. And that's exactly what we get. Key value 1 as the value of uno. We're going to go ahead and add 2 equals dos, then print. This is considered one object pair in a dictionary, and then this is the next object pair in the dictionary. Key value pairs. So here, we're going to call on a dictionary. Within the square brackets, we're going to call on the value or the key of 2. And when you call on a key, it gives you back the value. When you call on a key, it gives you back the value. Super important for your individual lab. And then you could use in if you want to and be super powerful, right? All kinds of fun stuff. Take a sip of this real quick. So, moving on, we have one in my dictionary. True. Uno in my dictionary. False. Well, it is. Well, in only checks keys. That's one little nuance you got to remember. In only checks keys in a dictionary, right? Let's move on to this. So here we go. Have no fear because there's a methods or there's a value method. So now we could take all the values in our dictionary, store them in a variable called vals. So we're saying, hey, my dictionary, give me all the values, store them in vals, print the values as a list, and the values are right here. Now, when you see this, that's what you get when you print the actual. You notice I'm changing, calling on the vals, print vals, and then I'm saying list the vals. It's a list inside of a dictionary value. So you have to transform it to a list by using the list command, right? And now all the values are indeed just a list. Technically, you don't have to do that if you're just working with them. If you're going to manipulate them or update a different object, it's been a long day. You want to store them in another variable to manipulate. But right here, just like everything else, all the fun stuff of length works. Length of my dictionary is 2 items, but it's 2 key value pairs. That's considered one item, a key value, and then this key value, that's 2. That's where we get the 2 from right there. Min and max still work, but they work only against the dictionary keys. So here you have the min and the max. But wait, there's more. Right? So this is where the fun comes in. You probably use something like this in your individual lab. So here you have counts. You have a dictionary of a parrot 1, cheese 42, spam 100. Key value pairs for key and counts. Okay, for key and counts, print the key. And then when you call on the dictionary with the parameter of the key, it's going to give you back the value. So here this should say parrot 1, cheese 42, spam 100. That's exactly what it does. Right? Not too bad. Now here we have our counts. We got our key list equals counts dot keys. And then print our key list. You notice when we print our key list, it's just our keys. It's parrot, cheese, and spam. And then we call it, turn it into a list and print it. We did that. Then we sorted it. And then now we say for each key in key list, print key counts key. So now I get the value. Pretty cool stuff, right? Let's see what else this does. Adds it to a key list, prints it, lists it, sorts it. That says for each key in my key list, print key counts key. Basically the same thing, but here it counts on, since we sorted it, counts cheese first, 42, parent 1, spam 100. Super helpful, right? It really is. Now we scroll down here. We'll see that. Oh, this word brown source already? So this is just counting characters, right? Now, there's a couple different ways you can do this. We're going to go with this way. So we have the word brontosaurus, empty dictionary. We say for each letter in my word, I knocked this off, I apologize. For each letter in my word, if letter not in dictionary, add the dictionary with the value of 1. Else, if it is in it, add it to the dictionary, but just take the value of letter and add 1, right? So we call on it. It goes through the whole thing, all the fun stuff, and I don't think I printed it. Yeah, it is. And this is what we print out here. 1B, 2Rs, goes through them and just adds 1 to the counter. That's all our logic says. Get method. This is cool if you want to check a dictionary to see if there's something there. But you notice what we're getting. Counts.get spam. Right? Get spam. Get spam from counts. Spam. When you call out a key, you get a value. Awesome. Let's see. Now it's got more heavy lifting with get. Okay, so here we're going to rip through this and create a dictionary. We create an empty dictionary. We have our word, brontosaurus. The whole string is in word. We're saying for each letter in word, dictionary is a letter. Dictionary get the letter 0 plus 1. Right? So B, that runs through the dictionary.get, that adds 1 to the value. Well, since B was just added to the dictionary, it has a 0 value, added plus 1. There we go. Good job. If there's 10 B's in a row, we would count each individual 1 10 times, and you're looking at your letter would say B.10 right there. Excuse me. It's dry in this hotel room. It's killing me. So that's the power of dictionaries. I highly suggest you watch this again or roll through everything in the book, because this section right through here, all the way to the bottom here, this is basically how you're going to complete your individual lab. Let's see. Now we're going to go tuples. Tuples are like lists, except they're immutable. You can't edit them, really. Now, it's important that you learn what they are, because when you work with a lot of databases or different data types, those databases will return tuple objects. Nothing wrong. You can turn them into a list if you need to. 9 times out of 10, you don't have to, though. Right? It's kind of like a low budget, don't tamper my object. So let's see what we got here. We have a T1, A, and a nothing. We ask the type of that, and the type we have is a class tuple. You define a tuple by an open and closed parenthesis. You could use the tuple function as well. Here we go right here. Tuple class print T, and it breaks it off into a list. So you go through each one. Pretty cool stuff. Now let's talk about the bracket operator and indexes on an element. So same thing. This is a tuple, right? Square or open close parentheses, not squares. This is a tuple. T30123 D print D. That's what you get. So there's that sort of assignment, but you can replace. Now watch this. A, B, C, D, E. Now we say capital A, comma, 0, nothing, close, plus T, plus our list, plus 1. So it's saying in the first indice, the value is 1. So it changes this whole dynamic. Right? Yeah, that's it. So then right here we say T equals capital A plus T plus 1. Well, start at 1, go to the end. So B through C, and this is how we replace the little A. Cool. Well, we can move on with more strings and sort words. Here we have a text variable. It says, but 'tis a flesh wound. We're going to split it with nothing. It's a space. So we're going to get our list of words. And now we create an empty list. We say for each word in words, add the length of word to word. Okay. And then print the word. Okay, we'll see how this goes because words split text and word and print word and all this fun stuff. We're gonna reverse it, but then print that. So we should have a three but tier, 3 but tis. And let's see where we're at here. Yeah, it works pretty good, right? Let's rip it right through it. Now this, a little different. We're gonna sort it in space. Let me see. Have fun. We're down there. Something I gotta go up on. So here we're saying words. Tis but a flesh wound. Empty list. For each word in my words, append it to the length of the word. Print word. List dot sort reverse equals true. Print T. Res equals list, which is just creates a empty object in res. And we say simply for length of word in T. That's pretty cool, right? If length of word in T, that's an update, append the list with word. Right? So if you're wearing the wrong kind of shirt or something. Perfect. Now, let's take a look at this tuple assignment. M equals have fun. X, Y equals M. You guessed it. M will be have fun. X and Y will be broken on the spaces. Each be their own variable. Pretty handy to do, right? Let's take a look at this. So we got movie times. Here we go. So this is literally, let's see, we got the movie times. What else we have? We have breaking apart a domain and a name. This is probably one of my favorite things to do. I do use this all the time. Like this is a name and this is a domain, and I'll just split it and I'll say split the at symbol and have two variables. So mine goes in one, and whatever it goes after the at symbol goes into the second variable. And then when I print them each, I have my at python.org, right? That's exactly it. It's not that hard. Which is fun because you could search for, does that domain exist anywhere in our headquarters? Does that user exist anywhere in our headquarters? You could do fun stuff like that. Dictionaries and tuples. Here we go. So just like calling dictionaries earlier, right? So here we have a dictionary called d.items, print t, sort, print t. So what do we got here? Print t. 10. Sort it. You notice it gives a variable first. A10, 22 Charlie, 1 Bravo. There's Ohio there. So, of course, OH, and then Ohio right here. Works like a boss. Now, import. Import random. Import random does that. Imports the entire module. If you're only going to use choices or choice or something, just import that one. Import blue, whatever my list is. Let's see where we at here. Okay, so we created we're talking tuples. It's still fun. We'll just go random. So this will help you out, right? This is a key value pair. This is your, what do you call it? Your state abbreviation and state name. So now we say random.choiced list states.items. Open close parenthesis. So randomly, it'll go through and it'll give you a state name. Random choice list state names, right? See if that works. Yep. And the way it has it over here is random.choice list.state.names. That'll say print D equals, there's another dictionary, A, B, C, D, Ohio, Ohio. For a key and value in D items, print value key. So this we just flipped it around, print value key. So 10 alpha's right, 22 Charlie's right, 1 Bravo's right, and OH Ohio's right. Dictionaries are the coolest thing you can leverage. No joke. Let me see. I think we're almost done for tonight. Let's see. Let me try it again. Come on. Huh. Just again. Not open. Here we go. That's lesson 6. Somebody else's stuff. Gotta find the lessons, right? Autumn. Lesson 6. And what was that? We said. Yeah, key value, key value list. States the item, so it turns these into a random list based off of the item and gives you back the key. And you can check it here, key value in D items. Let me see. Let's see if it makes you read the bottom. Yeah. And then you call on value key and you get the value in the key. So you see that when I call on the item, key value, right? So key and value, It's literally saying is for A with the value of 10 in dictionary D times, print the key value. No problem, right? Everything's a 1 anyway. But dictionaries are your best friend. Key value pair, get, items, and in. Get and in are probably the best things you could use in reality to get that Boolean back. Super fancy, super quick. And I think that's it for this evening. I want to go back over to the lessons. That one's just a pen. I'm really not too worried about that. See, we got a chat. What's up, chat? Partial use part dictionary lesson, group 5, for all the pirate words. I explained why I use it. Well, we'll see. Yeah, as long as you explained why you use it, that's fine. But just remember, Christian, that's not the focus of the lesson. The lesson is, do you know how to use find, replace, all the things that are covered in lesson 5? That's where you want to master that stuff. You know, I mean, yeah, you can do it advanced ways, do a complex object of a dictionary, but did you have to? If you could use slicing and solve that problem. So it's all about the critical thinking skills. Remember, it's not about Python. It's about mastering the fundamentals of the moment and using critical thinking skills to use the new tools you learned that week to solve the problem. But yeah, I'll check it out. All the grades will be done tonight. I'm going to grade after this. But yeah, I'm sure that'll be fine. And usually, you know, if you could leverage a dictionary successfully, you could leverage a list. You know, the dictionary is a bit more complex. Let me tell you the reasoning on why it's important to know how to use a dictionary. A lot of things in Web 3.0 or, you know, the Web 2.0, Web 3.0, when you interact with APIs, the data from different data sources, it's usually JSON or XML. So JSON is nothing more than a dictionary of dictionaries. So you can traverse them relatively quickly in Python. That's an awesome thing. This is where you cut your teeth. You learn how to use dictionaries. Lesson 8, I'll show you how to carve up a JSON file. It's very similar to this lesson, but you can use it to do whatever type of data carving you need. And with join and slice, you could make data look pretty. Slice data from one point from the beginning to the middle, clean up the end with using your reverse stuff, and you could really clean up data with join and slice is pretty good. Why would you want to do that? Well, data science, a good 40% of data science is just making sure your data is normalized. And that's a fancy term for meaning cleaning up your data. If you pull in data from 10 different sources, I'm not saying 10 different computers, Windows computers. I'm saying if you pull it in from a Windows computer, an Oracle database, a Hadoop database, a website API, and a router, can you normalize that data to where an IP is indeed an IP? Like the key value pairs are correct, and it doesn't say IP adder or IP address or I_P_adder. You know, normalizing your data and cleaning it up and finding it, replacing it. It's all part of the game, especially when you move into like big data platforms. But that's about it. We'll do the group exercises next week. This was relatively easy. Just create an empty list and use append to feed your numbers into it. It's not that bad. And that's just, you know, for each item in my range of numbers, add the number to append to my list. That's it. But there's no gotchas in this one. Like I said, a dictionary solving this individual problem. We'll probably do that next week. It's 2. I'll run through the lab. Let's go ahead and turn off the recording now. See where's that? Let's pause Let's pause the share. Pause recording. It's right in front of me. I'll stop the recording.